Malaria is a serious and life-threatening disease known to cause violent fevers and red blood cell destruction.
It is caused by Plasmodium parasites primarily transmitted between hosts via the female Anopheles mosquito. Malaria remains a global endemic, showing prominence in countries such as South America, Southeast Asia, and Africa. It is an ongoing burden on global health, with the demand for effective chemotherapeutic drugs growing stronger. Despite this, malaria is treatable with current medications, which are divided into first, second, third, and fourth-line drugs. However, with the growing drug resistance in malaria, specifically the Falciparum strain, has created a rising need for more effective fourth-line drugs. Mefloquine, also known as MFQ, is a synthetic derivative of quinine, currently stands as a strong contender on the front line against malarial resistance. The complexity of developing a new drug lies within the three life cycles of malaria: asymptomatic exoerythrocytic life cycle, the symptomatic erythrocytic life cycle, and the vector sporogonic life cycle.
MFQ reportedly targets developing blood Schizon stages. However, the principal antimalarial mechanisms are still not fully understood. It is believed that MFQ strongly targets and inhibits the parasite's ability to take up food and essential iron for survival in red blood cells.
Conversely, a recent article published in Nature suggests this may not be reflective of the true mechanism of action, as the PGH1 enzyme transporter produced by resistant parasites actively remove and inhibit the antimalarial drugs out of the parasite. In this article, it states that the active form of MFQ binds to the ADS ribosome, which is responsible for protein synthesis. The lack of protein production prevents the cell from conducting basic functions and results in the death of the parasite. Mefloquine is available in the form of 250 mg tablets, with drug regimen of 750 mg orally, followed by 500 mg 6 to 8 hours later. The drug is well absorbed into the bloodstream. However, there is a marked inter-individual variation of time to achieve peak concentration, ranging from 7 to 24 hours. With a volume distribution of 20 liters per kilogram, this means that the drug can be mobilized to tissues extensively, killing the parasite. MFQ is metabolized in the liver by a CYP453A enzyme into inactive compound and undergoes enterohepatic circulation, contributing to its long elimination half-life of 2 to 4 weeks. Consequently, MFQ is known to cause a range of side effects such as headache, delirium, vomiting, and nausea. But the major concern is the likelihood of positive neuroleptic symptoms, including hallucinations, delusions, induced nightmare, and the exacerbation of post-traumatic stress. This is due to its shared structure with other psychomimetics, particularly the hydrophobic properties of MFQ, which grants the drug the ability to enter different compartments of the body, including the brain. In the brain, the drug acts as a signaling molecule interacting with cell receptors, namely the serotonergic 2A and 2C receptors, causing neurotoxicity.
But if the effects are so adverse, why should we continue to use it? Many studies cite that Mefloquine as a co-therapy is very effective in direct symptom alleviation and chemoprophylaxis compared to other antimalarials.
An example of this is a recent study testing the efficacy of Mefloquine as a combined therapy with leading malaria chemoprophylactic artesunate versus common first-line chloroquine in testing uncomplicated malaria. This high-volume sample size randomized trial reported key findings of artesunate MFQ having significantly faster rates of fever and parasite clearance by as much as 90% of test subjects compared to chloroquine counterpart with only 60%. With additional benefits in greater killing activity of early ring-form malaria stages, minimal development of morbidity and lack of adverse effects for artesunate MFQ than chloroquine. This highlights Mefloquine's still prevailing clinical significance. Mefloquine has contributed greatly to the global effort against malaria, acting as a frontline treatment against first-line resistance, effectively providing hope to sufferers in high endemic malaria areas. In Western populations, MFQ remains relatively inexpensive and accessible to sufferers in clinical settings, yet these same benefits are reversed for impoverished communities of Africa and Southeast Asia, with the entry costs for admission bearing too high. Furthermore, MFQ as a complementary therapy with artemisinin is under strong recommendation of WHO, accounting for the significant reduction of malaria deaths in recent decades. However, upfront expenses of this combined drug treatment still remains unattainable to poor countries. One can argue that such costs are offset by the reduced time of discharge in hospitals, having a lesser economic burden on healthcare. Additionally, MFQ's significant adverse effects pertain social ramifications, particularly pregnant women are contraindicated. Overall, Mefloquine still prevails as a worthwhile treatment.